Now let's create an analysis of variance table. I'm just using these three columns. Now they're all the same size, but they don't have to be. So we start with our data. I went ahead and created the labels for the things we're going to need. We're going to need the sum of squares treatments, sum of squares errors, total sum of squares, degrees of freedom for the various things, our mean squared treatment, mean squared error, and our F value that we get. Then we'll compute our F distribution, get the p-value. We're going to need some averages and so forth. So let's get started. I would like the column average. Now here's an important thing. These all are the same length, but they don't have to be. And so for instance, suppose this middle column was a little longer. Well, that's fine. I can come way down here like this and still compute the average. The empty cells don't do anything, and so I'll get an average of 4 there, and if I just pull it across, it will get the averages of each of these. Similarly, finding n for each column, I can do a count, and once again, I can do more than the column, and that doesn't matter. And so if you have a longest column, just do this for the length of whatever the longest column is, and then again just copy everything over. Now in this case we'll get 8 for each of those. Now we need our grand average, so equals average of everything. And once again, you know, as long as you aren't getting numbers that shouldn't be there, you know, it doesn't matter if you're getting an area that's too big. You just want to make sure you know what you're doing. And so we get 5.83 there. So now I want to calculate my sum of squares treatments. Well, to do that, I need to take that n and then times the difference between my column average and my grand average. Whoops, my column average, and then minus my grand average. But now I don't want, you can see it better up here, I don't want that grand average to move as I copy things across, and so I don't want that G to change, so I'll put a $ in front of it, and then I'll square that, and I'll do that for all 3 columns. And so now I can fill in my sum of squares treatments, and that's just the sum of these 3 things. And again, you know, I can have more in there. Wouldn't be exactly efficient, but just to point out that you can, if you have different size columns here and so forth, you can do the biggest column and copy and paste and so forth using that. Okay, so then the next easiest thing to get actually is the total sum of squares, and the way I'll get that is I need to find the difference, so equals the difference between that value and my grand average. Now, but again, I'm going to copy sideways and down. I don't want that to change the G nor the 14, so a $ there, $sign there, and close that off, and then square that. And now if I just pull this down, pull it over, now I did way too much, but the nice thing here is I can tell where I did too much. Notice these numbers are all the same. Oh yeah, that's because I went one too many column. Just delete that. Here again, oh yeah, those are all the same, and then of course I got into other numbers down here. But you can just look and delete the ones you didn't need, and so now I have that, and my total sum of squares is just the sum of all those things. Now, to get sum of squared error, that's just the difference of these two. So take your total sum of squares minus that one, and enter, and there we have it. Similarly with degrees of freedom, my total degrees of freedom are this count down here minus 1, so I'll sum those up. Sum all of those, so 24 is what I'll get, but minus 1. So my total degrees of freedom are 23. Up here, this is easy. I just take my number of columns, which was 3 minus 1, and I get that. And then again, this is just the difference of the two rows, so equals 23 minus the 2, enter. And then mean squared error is just my sum of squares treatment, or mean squared treatment, sorry, is sum of squares treatment divided by the degrees of freedom. And similarly here. And so, see, actually I could copy that and just paste it here if I want, and get those two values. And then my F number is just that number, MST divided by MSE, and there it is, 11.064. Now, for my F distribution, then, well, if I know the formula, I can do that, but if I don't, which I don't remember exactly what it is, I can go in here and insert it. I need the F distribution. Now, there's this nice thing that says F test that won't help, but we need our number, so our 11. Degrees of freedom 1, well, degrees of freedom 1, that comes from your degrees of freedom of treatments, or between treatments. And then 2 is the sum of the degrees of freedom error. And then cumulative, yes, we would like cumulative, and we can see the number there. So that's our or that's our cumulative distribution. We need actually 1 minus that, because we need on the right side, not the left side. So I'll get my p-value that way. And there's my p-value. 3 zeros and a 5. So very small p-value. Now again, just to show that you can have different lengths, because I had copied some extra stuff, actually if I toss in a 4 here and a 3 there, things keep changing because they were part of that average. Right, so there's the average. It went clear down to C12, so that's fine. The count also went to 12, and so that all is fine. Now I've got a problem here in that I need those two there. Now, if I had just done everything like that, well, that's okay. Then you just come in here and delete those pieces that you needed. And now this is also still a 2. That's now at 25. What I don't know is if my sum of squares total was big enough for this, and so no, I see it's not, right? And so I'll just highlight that and highlight all of that. But notice that's fine with the blank spaces, and enter. And this should have updated everything then, because those are fine. These all come from here, so you see you can have a different length for a given column. Just highlight, everything. So, I would go there to do my averages and so forth. And then just delete what you don't need here. Okay, so that's an analysis of variance.